Okay, so we're going to be looking at some examples of legacy code now. So what I mean by legacy code is code that perhaps doesn't adhere to these good design principles that we've talked about, these principles that are going to make our code easier to test. This could be for a few reasons. Maybe that you're interacting with a lot of third-party libraries. It may be that you're using some internal libraries that you're not in a position to change. Certainly you wouldn't want to be changing your existing code purely to make it easier to test. You may look at refactoring it as part of development to make it more maintainable, but it's not really practical to just refactor it purely for the purposes of a single test, for instance. And refactoring it without a test would also introduce a degree of risk. So there are a few reasons we may have code which isn't easy to test, is not easily testable. So what we're going to do now is look at an example of some code which isn't inherently testable, is not easy to test, not easy to inject test doubles into, as we have done previously. So here we have a user service. It's a simple imaginary service that allows us to create users on a system of some form. So we have a hash map of user ID to username. We have a method that allows us to look up the username given a user's ID. And we have a method here which allows us to create a new user. So given a username, inserts an entry into this hash map and returns the user's ID. Now this method isn't easy to test because it's using a static method on an ID generator class here. So looking at our ID generator, it's a very simple class, probably too simple an implementation for any real purpose. The important thing is there's no interface here. The only way user service interacts with this ID generator is through a static method call. If we had an interface, we could stub that quite easily, but we're not in a position to do so with this static call. So what we're going to look at is how we go about replacing that static method call with a stub that's going to return us a known ID for use in our test. So the way we're going to do this, we're going to use a library called PowerMock. Now, what PowerMock does is it uses bytecode manipulation to allow us to mock classes that would otherwise be fixed. So it's actually injecting code around existing bytecode to allow us to create mock objects and do things like mock static method calls, constructors, private fields, and so on. So our test class, it looks pretty similar to test classes we've seen previously. There's a couple of differences. Firstly, at the top, you'll see there are a couple of annotations, the run with annotation and the prepare for test. Now, both of these annotations are needed in order for PowerMock to do that bytecode manipulation we talked about. So we need to be running it with our PowerMock runner so it can do the manipulation. And in prepare for test, we need to tell PowerMock about the classes we want to be mocking, the classes we want it to be manipulating. So, similar setup as before, we have a user service we want to test as a field, and we have a test setup method that creates our user service for us. Only difference here is we have a mock static call, which is a call into PowerMock, which tells it that we want to be doing static mocking on this ID generator class. Okay, so on to our test method now. With PowerMock, as with other mocking frameworks, our test is going to follow a three-step pattern. There'll be 3 stages to our test. The first stage will be setting expectations on our mock. So if you remember, mocks have to be pre-programmed with the expectations, so we have to tell the mock what method calls to expect to receive and what values they should return from those method calls. So what we're doing here is we're saying, well, we want our ID to be fixed, value of 1, and we're saying when generate unique ID is called on our ID generator class, when the static method is called, we want to return our ID as a return value. So that's the first stage. We're now going into the second stage where we're actually executing the the method that we want to be testing. So what we need to do is we need to put our mock, in this case the ID generator that we're doing this static mocking on, we need to put this into a replay mode where it's suitable for executing normally. So we're done setting expectations. Replay mode is where we now interact with our mocks, where our real application code interacts with those mocks. So we're testing create user, so we're just calling create user with value of Bob. Now on to verification mode. So we switch our mock from replay mode to verify mode. And now we're going to make the assertions that we need to in our test. So here we're looking up our username, given our ID that we know the ID generator will have provided to our user service. And we're making sure the return of get username is Bob, our newly created user. Okay, so that's how we go about mocking static method calls, which is pretty common to see in a lot of code. Also want to look at how we go about mocking new object creation. So you'll have code that creates new instances of classes, and you want this code to interact with mocks rather than the real instances of the class. Let's go back to our user service now. So expanding our create user directory method. And what this is doing is it's simulating creating a user directory. So given a directory path, we'll create a new Java IO file for that path, and we'll see if the directory exists. If it does, we're saying that's a violation, we'll just throw an exception. We don't want to be called in that case. It's an exceptional case. Assuming the directory doesn't exist, we'll call makeDirs in the directory on the Java IO file. So in order to test this method, what you'd want to be doing is injecting a new mock here. So rather than creating a new file, a real Java IO file, we want to be providing this code here with a mock to isolate it from our file dependencies. So let's go back to our test now. So we've got a new test method here. The test setup we haven't changed at all to do this. And this test method follows the same three stages as we saw with our previous test. The difference is rather than doing just a static method mocking, we're actually creating a new mock object, and we're then injecting that mock object into our application code. So firstly on this line, creating a mock for the file class. And here we're setting up the construction. So what we're saying is we expect a new file class to be created with a constructor which has a single parameter, the value of Bob. When the constructor is called with that value, rather than returning a normal Java IO file, we want to be returning our mock object, our file mock. So then what we can do is we can set a couple of expectations on that mock. So when file exists is called, we're free to return false for this particular test. And we're saying when makeDirs is called, return true from that method call. So on to executing our tests. Again, we switch the mock into replay mode, but because it's not a static mock, it's actually a mock instance, we have to switch that mock individually into a replay mode. So we do that like this. And now we're calling into our application code, calling into the user service that we're testing, we're calling create user directory for Bob, and asserting that it returns the value of true. So this is going to interact with our mock object. Because we know our file will have been created with the value of Bob as its constructor parameter, it will now be using our mock instead of the real file. So now we can just switch our mock object into verify mode. So we'll verify we haven't had any unexpected method calls on that mock. Okay, so we've seen a couple of ways in which we can use a library like PowerMock to enable us to test application code which otherwise would have been impossible to test. We would have been forced to perform some pretty significant refactoring in order to test code like this before. If it's a third-party library, or even an internal library, we may not be in a position to perform those modifications. And even if we were, we may not want to do so at that time because it would be very risky. What we want to be doing is focusing on building new functionality. So using a library like PowerMock enables us to introduce tests into an existing system, which is then going to give us the foundation to start improving the system, to start building upon it in a test-driven fashion.